Is this sum that has been done weirdly by so many formulas, and well, people arrive at the answer, but I'm surprised having looked at how learners do it differently. And I thought we really need to give them what really is intended in this kind of question. I just want us to do it. Four men can build a stone wall 32 meters long in 12 days. What length of wall can 8 men working at the same rate build in 8 days? So that is the kind of question I want to dissect. And I know we all have our own kind of ways of doing it. But let's put that information together. We have men that will be represented by M doing a given length of wall in meters and taking a given number of days. All right? So we have 4 men building a stone wall in 32 meters in 8 days. Sorry, in 12 days. And we are told what length. So the question is on what length can 8 men working at the same rate. So again, it's important to note that these people are working at the same rate. Do build in 8 days. And I want us to try and dissect this question. Before we even do this question, I want us to understand this question in 3 bits. This question is about ratio and proportion. Most importantly, proportion. How do we define proportion? Proportion is simply a comparison of two ratios. So the first thing we need to know is direct and indirect proportions. This is aspect number 1 of this question. We are going to see how men relate to the length done, or how days relate to the length done. And that can either be in either direct or indirect proportion. Direct proportion is a situation where if one quantity increases in the ratio of A to B, the other quantity will also increase in the same ratio A to B. It is direct. Like, for example, the distance covered by a car and the fuel consumption. The further you go, the more liters of fuel you will need. That is a direct consumption, direct proportion. When we say and vice versa, we mean that if there's a decrease in a given quantity in the ratio A to B, there will be a corresponding decrease in ratio of A to B. That is what we call direct proportion. Then what about indirect proportion? Indirect proportion comes about there if one quantity increases in the ratio of A to B, the other quantity will decrease in the ratio of B to A. And I know this is where the problem is. One quantity increases in the ratio of A to B produces a corresponding decrease in ratio B to A. And vice versa. Don't forget that. And vice versa means that if there's a decrease in the ratio of A to B in indirect proportion, then there will be a corresponding decrease in the other quantity in the ratio of B to A. All right? So these two are very important. Very, very important. Number 2, the next thing we need to understand is how does increase in ratio happen? The increase in ratio happens, like for example, when we say a quantity increased in the ratio of A to B. This A becomes the new value, ratio old value. This is how this thing is. A is the new value, B is the old value. If there was a decrease in the ratio of B to A, then this is also B becomes the new value and A becomes the old value. So when you see that a ratio was increased in the ratio of a quantity was increased in the ratio of A to B or decreased in the ratio of A to B, then the first one is usually the new value in all of them. Then finally, number 3, if you want to get an increase of a quantity in a given value, it is usually a new value over old value times the number. Very important to note. If I want to know in what ratio or how is the increase in men or decrease in men going to affect the length, then I must know that the value in which a quantity increased or decreased is a new value over the old value. Having understood these 3 concepts, then we can now go back and solve our sum process.